All right, so this is day 3 of lesson 16, and today we'll be using elimination to solve systems of equations. So we start off with this system. We have negative x minus 2y equals 4, and then 3y equals negative 0.5x plus 2. All right, so in the model, they already answer every single thing that you need to know for this problem. They've solved it, they have their solution, and they checked it. So if you haven't been doing this so far, make sure that you always check your solution to ensure that you're correct. And so this is the check it section right here. And all you need to do is make sure that you end up with a true statement at the end, and if so, that means you've done it correct. All right, so this is a true statement because when you simplify, you get that 6 equals 6. So that means your equation or your solution that you got is true. Okay, and the solution here was that x is negative 8 and y is 2. So as a coordinate, it would have been negative 8, comma 2 here. All right, and so then we're going to move on to those connected problems. So number 10 says, what happens when you add opposites? And do you want to get opposite coefficients for one of the variables? So when you add opposites, you get 0. Any number plus its opposite is 0. Okay, and so why do you want to get opposite coefficients for one of the variables? The reason you want to do that is so that that set of variables eliminates, so that you only have to focus on one set of the variables. You do that to eliminate, and you eliminate so that you can focus on one set of variables. All right, moving on. How did you get opposite coefficients for x in the solution on the previous page? Well, what they did was they went ahead and they multiplied that second equation by 2 in order to form a set of opposites. When they did that, they just distributed the 2 to all the terms in that equation. And what was really important was they multiplied the 2 and the negative 0.5, because then we would have had our negative, or our negative x. All right, great. And I believe they should have, I'm going to leave that alone. Okay, I'll just leave that. All right, so then it said, how did you get it? They multiplied by 2. And you multiply all terms by 2. All right, number 12, why does the equation stay balanced when you add the values on each side of the equal sign? It stays balanced because what you've done to one side, you did to the other. Okay? Because you added to both sides and not just to one.
These folks asked us to copy these for in the copy room, and we don't want to come in.
All right, number 13, which equation in the system was used to find the value of x? So the one to find the value of x, they used it looks like they went in and used this one, which was this first equation. They did all that good stuff, it looks like. All right, so they used that top equation. And then it says, can you use the other equation? Yes, because you know the value of y. Oops. Because they already found the value of y. All right, number 14, how is elimination like substitution? You end up substituting either way. And then how is it different? Well, you end up eliminating, or you might have to multiply in order to substitute, in order to get to that substitution step. So that's how it's different. They're the same because you end up doing the same steps, but then they're different because you end up having to either multiply or divide, but you end up adding a set of opposites together to get that variable or that set of variables completely out of the way, okay? Because you have to have a set of opposites for elimination. And then how can you check your answer? You just plug in your solution or substitute your solution into one of the equations. And then if you come up with a true statement, then you've done it correctly. A true statement means that your solution is correct. All right, and then we just move on to the triad for today. So again, today's lesson, day 3, it focused on elimination. So remember, for elimination, you need a set of opposites, or you need to create a set of opposites. So I'll underline that. For elimination, you need a set of opposites for this to work. A set of opposite variable terms. That makes it sound good. Okay, so if you notice in number 16, we already have a positive y and a negative y. So you can just add when you have that. Well, 2x plus 3x is 5x. 1y minus y is 0. And then 9 plus 16 is 25. So I really just have 25 is equal to 5x. I divide both sides by 5, and we find that x is equal to 5. When you know that x is 5, just plug it into one of your equations. Doesn't matter which one. So we'll do 3 times our x minus y equals 16. I just chose to use that second one. So 3 times 5 is 15 minus y equals 16. I'll subtract 15 on both sides, and I find that negative y equals positive 1. I don't want negative y, I want positive y. So I just swap everything, and I find that, I'll rewrite that, that y equals negative 1. And the last thing I need to do is just check my solution, and my solution was my x was 5, my y was negative 1. I just plug it into one of my equations, and I'll use the top one this time. So I have 2 times my x, which is 5, plus my y, which is negative 1, equals 9. Well, 2 times 5 is 10, plus negative 1 equals 9. Well, 10 plus negative 1 is 9. Is 9 equal to 9? I came in with a true statement. I'm correct. All right, and that is all for day 3. Thank you.